we have the slides? So, folks, I have a very serious question for you today. Who here knows how a microwave oven works well enough to build me a new and better one from scratch? Raise your hands. Come on, no microwave builders? What? Different question for you. Who here has never used a microwave to heat food? Interesting. So, well, diversity is good. I see one hand going up. But most of you here in this room, you're telling me that you have used a microwave and you have no idea how that thing works. Why do you trust that microwave? Well, you can't tell me the wiring diagram. Well, you're not going to trust it by reading that wiring diagram, are you? You're going to trust it because you're going to think about what it needs to do for you. We have some, good. And then you're going to check that it has delivered. That is exactly what you're going to do with machine learning and AI in practice. In fact, I've got this analogy that I love with kitchens about machine learning. And I want to point out that we make it sound like there is just one discipline of machine learning and AI here. But actually, there's more than one. There's at least two. The first is the one that you would take a university course on, the one that you're used to talking and thinking about, the one all about the algorithms, which are like the microwaves and appliances. It's about building those algorithms. Now, if you want to innovate in microwaves, if you want to build a new and better one than the one that's already existed, of course you need to know how that thing works. And of course you need the wiring diagram, and of course you need that decade of study. Makes sense. But the thing, people have been building these microwaves for a while now. And there are warehouses upon warehouses of them, all ready to be used by people who want to innovate in the kitchen, who want to apply them, who want to cook. These are two different jobs. Building microwaves, building new kinds of recipes. And when we lump them together, all kinds of things can go wrong. If you want to get cooking, you want to open something like McDonald's at scale and innovate in those hamburger recipes, and you decide to open your industrial scale kitchen, and you only hire 20 copies of the same kind of microwave builder, that same kind of researcher, what could possibly go wrong? If you've been building microwave components your whole life, maybe those skills don't transfer directly to cooking. And yet, this is something I see businesses doing all the time. They themselves. Am I just going to have to? I was thinking of theatrically beginning to project, but then when the mic goes back, I might make all of you go deaf. But that's a backup. We have that backup. So if you hire these microwave builders, what could possibly go wrong? So they don't know necessarily how to cook in your kitchens, and also, when they think about innovating in microwaves, they tend to use benchmark data sets, benchmark sets of ingredients that are all the same for checking the microwaves against one another. They're not actually trained in the specifics of grocery shopping, and not just grocery shopping, but grocery shopping at scale. Get me 20 tons of ice cream and don't let it melt. That's what data engineers do. Bring those ingredients, bring that at scale so that you can do good things with it. Now, let me show you how machine learning works and introduce you to decision intelligence, which is applied side. You could think of it as just applied machine learning plus augmented with the social and managerial sciences, but I think that we too much conflate these two disciplines so that it becomes unclear for businesses. What are we actually trying to do here? Are we trying to innovate in recipes, in food, and solving new kinds of problems, which is what decision intelligence is all about? Or are we trying to build a new kind of microwave, which is what traditional AI and machine learning research is about? And when you get those two things confused, of course, lots of things can go wrong in trying to apply this. Now, of course, as people want to innovate more and more in kitchens, The role of the engineers that are building the appliances also grows, but that is a separate business, and you should know, first and foremost, what business you are in. Which one is it that you do? Otherwise, things, again, will go wrong. So what is machine learning? Machine learning, in a nutshell, is just thing labeling with examples. And let me show you just very quickly how it works for those of you who haven't seen into the black box. Very straightforward. You have data and you're attempting to label them. It's not just classification. You can also use it for making labels that are numbers or sequences or what have you. But here we have an easy task. Blue triangles, red circles. Your entire job, separate the two things. Make a recipe that separates the red. So you have got to put some kind of boundary between these data. Maybe you're thinking of using a line. Where will you put this line? Well, hopefully not straight across. You're going to use the data to decide where to put it. For example, there. That's what an algorithm also does for you. You pick the shape of the boundary, like line, and it figures out based on your data where that goes, so you don't have to do it by eye. And that boundary does not need to be a straight line. There's all kinds of possible shapes, and that's really what the differences between those gobbledygook algorithm names boil down to. What sort of shape are you going to put through your boundary? Then, once the algorithm is finished putting your boundary through it, what you get out is what you wanted all along, which is a recipe. A model is just a fancy word for recipe, and how we read this recipe is if the next data point lands in the red region, call it red, otherwise call it blue. That is what this is all about. And the AI side, the way that people are using the term AI today, tends to refer to a subset of this, where the algorithm used is that very flexible neural network. Same kind of thing. So why should you even be excited by this? Why bother? Well, here's a picture of my pet Huxley, and when you look at this, you just know that that's a cat. And if I show you this one, you're not fooled, you still know that that's a cat. How do you know this? If you wanted to automate this task, and you took the traditional programming approach, you would have to communicate with the universe, think really hard about the problem, and handcraft that recipe yourself, figuring out what to do with each pixel. But what did you do with each pixel to get that label? Do you know? Can you tell me? Can you tell me exactly, like, what happened to the second pixel in the top left-hand corner? What did you do with that? Your brain did something. You're just not aware of what that something was. And so it's going to be really hard for you to come up with those instructions explicitly here. Wouldn't you prefer to say, here, look at a bunch of pictures of cats, look at a bunch of pictures of not cats, and figure it out? That is the essence of machine learning. You are explaining yourself not with explicit instructions, but with examples. And you already have these two modes of communication when you teach humans to do things for you. Now you have unlocked with machine learning that second mode. And that's incredibly powerful because for some tasks, we just cannot come up with those instructions ourselves. They are ineffable. And machine learning allows you to automate the ineffable. It doesn't matter that you don't know how to do the task yourself. If you've got examples and you can see whether the task was done properly, then you can express your wishes with examples. Really powerful. But in order to do this well, and to apply it, you need to start having an applied discipline that is about building the recipe, rather than building the ability to learn, rather than building the microwave. Today, we have a problem. We've spent so much time building the microwaves that that's all we focus on. And we don't talk about how to go from an idea to data to the solution and then. If you are interested in decision intelligence in the applied side, your focus needs to shift from how does it work, how does the microwave work, so I can build on, to does this recipe do the job that I set it? And that's quite subtle. You need to come up with what that was and how you're going to know it was done right. If you're shown a picture of a tiger, should that be labeled as cat or not? Well, that depends on you and what you want the system to do for you. This will boil down to human creativity, and so you should start thinking about these things in terms of labels. What label are you going to want the system to produce for you? That's where you'll start. And here are some real things that we've done with Google Cloud Platform. For example, labeling baby food ingredients as safe or spoiled to protect kids. That's labels. Clouds versus snow. Is each pixel cloud or snow? Instead of doing it by hand, wouldn't you rather just have a machine do it for you? Then, how about the label being where to set the cooling system for a data center to optimize energy efficiency? Well, we let AI in our data centers at Google, and the energy efficiency increase that we got here was around 40%, which is incredible. It's a huge reduction in carbon footprint. Better than trying to do that by hand and writing the code for how to control those things explicitly. Why not learn them from data? Then if you wanted to caption and maybe translate my talk into Spanish, you could do that with AI. That's labels. The winning move in a game of Go, that is also a label. And, of course, where to turn the steering wheel, also a label or output that you might envision wanting to automate. If you can automate it with instructions, because you are able to solve the task, come up with those instructions yourself, please don't attempt to use machine learning. There's really no need for it. That's a solved problem. Solve it by expressing the recipe as a traditional programmer does, and off you go. It's when you don't know how to solve it that you want to go to machine learning. It's when your only hope is to use examples, not. So you can also think of this in terms of how you would communicate to do the task. If you can micromanage every step of the way and say exactly what needs to go where, then all you need is a programmer to translate that for you into language the computer can understand, and you're done. You've already described the steps. But if you cannot, the only way you can get it done is to rely on examples. But how will you know if it works? You'll know the same way a professor knows whether a student can perform a task. You want your student to learn calculus, presumably not only the examples on the board. You're not going to open the student's brain and figure out how that student does calculus. I'm glad you don't go poking around in the wet stuff. You don't know how your student's brain implements calculus. Let me just tell you that. But that's okay, because you're going to set an exam that tests whether they do the job properly. And so to stay safe, you're going to not only set this exam wisely, but you're going to make sure that you test the student on new problems they haven't seen before, so that they couldn't have memorized their way to a solution. That's how you fit that thing. That's how you catch that thing called overfitting. That's the big scary monster in machine learning. Simply avoid allowing a student to memorize their way to victory by giving them exam problems they haven't. Be careful with your testing. Make sure that your exam is relevant. You want a calculus-enabled student? Don't give them a Japanese language exam, right? And not only does testing keep you safe, you should also remember that your system is essentially learning from textbooks that you give it. That's your data set. It's a textbook. And that textbook is authored by people. So it's not an objective truth. It's just a textbook with human authors, data engineers, that you have given the student to learn. And that is all your student, your machine, will learn. Nothing else but what's in that textbook. So it really matters what that textbook is and whether it is appropriate and whether that is what you want your student to be learning. Because that's all your student will learn. So I tell my engineers, if you're going to go near machine learning, please tattoo this sentence on yourself. The world represented by your data is the only world you can expect to succeed in. And that data set, that textbook, it's made by people. So it's the responsibility of the decision maker, the leader, to open that textbook and make sure that that textbook is something you want your student to learn from. The rest is actually much easier than what people think. The core principles here are, your machine will learn from examples. To do that well, those examples have to be good and relevant. Those examples, that data, it is made by people. So make sure that it is made wisely by people, and make sure that some grown-up who's in charge has had a look and thought about what that textbook means and what it would mean to learn it. Then the other principle is, once you've had a go at attempting to learn in there, you will need to test this system, give it an exam on relevant questions, and for that to work, you need to be able to say what it means to do your task properly. That is up to you, the human decision maker, who's kicking that process off in the first place. So this isn't magical magic that you can sprinkle on top of your business and not worry about it. This is something where, at the very beginning, the human decision maker has to say what we're trying to do, how we'll know if it works, and then we'll test properly. And the rest is tinkering, dabbling, and playing in a kitchen. Just like with a kitchen. If you want to make calorie-free, delicious pizza, how long is that going to take you? Who knows if it will work out? Who knows if you'll need to invent some extra appliances along the way? The only way to start to get a sense of how this is going to go is to dive in and begin playing. And there are beautiful kitchens out there all set up. Google Cloud has one. There are many others. You can get them from academia as well, that are ready, waiting for you to dive in. So I hope that you're excited, because this is an incredible opportunity to make your data more useful than before. Don't only over-focus on making the microwaves. Let's start using them finally. Let's do great things with them. But let's also be wise and careful and stay safe, and remember that it is the human decision maker who makes or breaks the game at the end of the day. So I hope you're excited. Your machine learning adventure awaits. Thank you very much.
So thank you very much to Cassie. That was really interesting. I have a question to kick off, and then I think we're going to do a couple audience questions in the few minutes we have. So to start out, you talked a bit about being careful in what's in that textbook that you're training with. Could you talk a little bit about how we can be careful in trying to, say, remove bias from some of those data sets before we actually start using it to implement into AI?
So let me break that question down into a few components.
Sure.
So the first one, because this is the one that triggers me slightly, is this notion of bias. Now, bias has lots of different meanings, depending on the context that you use it in. And when we solve statistical biases, for example, which there's a long conversation about, all is the history of statistics pretty much, we're not addressing the stuff that the public today is most interested in, which is bias in that more colloquial sense. Sure. So first, watch out when you hear things like, we fixed bias in this data, have we fixed it in that statistical sense or in this other sense? That has to do with the human stuff. That has to do with the way that our past experience influences what we do next. And the trouble with the second one is I personally don't believe that it makes philosophical sense to talk about us as being objective or uninfluenced by our prior experiences. I can't believe that that we will be able to solve bias in data to an extent that while we're happy with it today, in 200 years our descendants don't think that we're a bunch of barbarians for having the social norms that we then optimized for today. So the objectivity thing, I think it's misleading, because as we say, we failed to solve objectivity, we also we let ourselves not do the part that we should be doing. And that part is trying our best not to be jerks. Understanding that at the end of the day, human context will be baked in. That doesn't give you an excuse to be mean. So fighting bias, to me, is strange language. Rather, I would say, let's make sure that the intentions are good and delivered, and that there isn't disproportionate effects of the data on some group versus another. But again, the groups that we identify today may or may not be the groups that in 500 years' time we find most relevant. So our way that we can protect against bias is through heavy analytics, looking at the textbook, thinking about who was the author, what might have been left out, which groups do we not know anything about in that textbook, and how might we we change that, it doesn't mean that the solution will ever be perfect. There's a second part as well. If your textbook is authored by only one person, then you take the entirety of that person's worldview and you base everything on it. So maybe it's worth thinking about bringing a diversity of perspectives into the authoring of those textbooks in the first place.
Sure.
So diversity of perspectives, I would say, hugely important. Being aware of what you're doing and trying your best not to be evil, not to be a jerk, that's important. But the idea that bias is a thing that can be solved, I think, takes a slightly naive perspective of what the human is and what human perception is, and now it goes into deep philosophy about whether there is or is not a truth outside of the human perspective.
Sure. Okay, I think we have time for just one more question I want to get in real quick. So we have a lot of people that are obviously business leaders and stuff here today, and I was curious, what do you think are the most effective ways that we can actually bring data science into building the organizational structure of a company?
First thing to realize is that there are different flavors of data scientists, and I've blogged about a blog post with the top 10 roles of data scientists. And so you'll see there that they come in different flavors. They are different. And how you plug them in depends very much on which type it is. But here's what I will say. An analyst whose job is to stick to bring inspiration from that data to potentially inspire decision-making. That worker makes sense anywhere and everywhere in every organization. Inspiration from data, but not taking it too seriously. In order to do any other kind of data science, statistics, machine learning, those types, for that, you need to have the decision who is skilled in place, who is able to say what we're trying to do for the statistics, how we're going to do our testing. Thank you. And for the machine learning, what is worth automating and how will we work with the testing?
Got it. Great. Well, I think that's all the time we have for, but thank you so much for joining us today. We really appreciate it. And now we'd like to invite you all to enjoy networking time and refreshments right outside these doors, and the program will continue at 10:30. Thank you all so much.
If anyone is interested in reading some of the things that I've written about this, I also have translations into Spanish, and so I put those up on my Twitter account, so that's what's on that front page there. So if you want to read some of what I have to say in Spanish, in English, that's all there.
Great. Well, thank you so much. Sure. Yeah.